Hello, everybody. Hello, hello. So I'm Rama Gottfried, and I'm going to give you a little tour of Drawsocket. Okay, cool. So yeah, I'm going to give basically a short introduction into what Drawsocket is exactly, and then I'm going to take everybody through installing it and go through some basic examples of use. So it does require Macs for the most part. That you can use it with PD also, but it requires the ODOT package. I'll explain more of that later. But if you don't have Macs right now and you're interested to get it running during the workshop, maybe while I'm doing this intro here, you might want to start downloading Macs. Just for, you can use the demo mode, should be fine, I think. Okay, cool. So Drawsocket is a framework, a server client system that we created for the Tunnel project in 2019. It was actually, the work was happening in 2018, but we did this big concert in the St. Pauli Elbe Tunnel under the Elbe River in Hamburg. It's these two long tunnels that go under the Elbe River. And each one is, I think, oh yeah, it's on here, 432 meters long. So that's more than a second of time for sound to move through the tunnel. And for this performance, as you can see from the image here, it's very site-specific performance, and the audience is walking through the two tunnels. And each performer in the orchestra, there were 144 performers, and between each two performers was a distance of 6 meters. So there was a very large spatial distribution of the performers through these two tunnels. And so what we needed was a way to synchronize as best as possible, synchronized in scare quotes, because of course, because of the acoustic distance, there's already built in some physical latency here. But we wanted to have a way to, as best as possible, synchronize the performers to a sort of conductor clock, a server clock, and to send separate views to each performer, just like you would have in a normal orchestra. Instead of having the parts on paper, each performer in the Elbe Tunnel Philharmonie, we called it, had a separate part on an iPad. So we had 144 iPads, all synchronized on the same local area network with a bunch of antennas spread out through the space. And so on this picture here, you can see, can you guys see my mouse when I'm moving it around? Just curious. Yes. If not, yes. Yes. Okay, cool. So this area here, I'm circling with my mouse. This is just an overview of the tunnel, and all these little dots are people. And as you can see, it was a big event. So here's a general schematic of the Drawsocket working model. You have some OSC bundles that are coming in, and they're addressed to different performers. And so these are just some examples of what it might look like on the different screens. And so we send in messages into the server, and those get routed to individual browser windows. And essentially what Drawsocket is it's a two-part system. There's the server and there's the client functionalities that are working together. But they do different things. The client side scripts are essentially a wrapper around basic web browser technology. So SVG, HTML, CSS, JavaScript, of course, and also WebAudio. And there's so many libraries and plugins for browsers that we can take advantage of a lot of that. And the Drawsocket client script, which I'll go into detail in a moment, what that does is it tries to create a sort of unified namespace so that you can address different parts of the browser functionalities with a sort of unified message syntax. And so here's just a little example of, of synchronizing scores. Georg just showed some of this in the max score example. But here you can see each part has a slightly different part, but they're synchronized in time, more or less. And here's some footage from when we were testing the iPads for the tunnels. And there were a lot of iPads. And just as an aside, I think it's, when you are doing this kind of networked setup, just like all performances with technology, I highly recommend really testing with the exact hardware that you're going to be using for your performance, because there are a lot of differences between browsers and stuff like that. Here's a very short clip of one of the pieces, and I was surprised at how in sync actually things were through the tunnel. Even though there's this giant space, the clock synchronization and our sort of psychology of piecing together time, I think, created a lot of synchronicity between the parts. So there was a paper also in 2019 that maybe some of you have seen already, that talks a little bit about the first workings of the system. And at the Hochschule, there's been also some students are starting to use Drawsocket in their pieces. Here's a short clip from one of our students' pieces. So that's cool. Okay, Symbolist, right. So this is for later. So I'm going to pause here. Cool. So there is now okay. Sorry. What am I doing here? Oh, right. Thanks, Vaughn. I'm going to post, let's see, new browser window. Okay, here we go. So I just made recently a new website for Drawsocket, which you can find at drawsocket.github.io. And this will kind of get us going into getting it installed and things. So just some more information like what I just showed you here. And there's a bunch of instructions. So a lot of what I'm going to tell you is available on this this website. Right. So for use in Macs, let's see. Go to my notes here quickly. Right. Oh yeah. So I wanted to show you this also. So an example. So if you go to the Drawsocket website and go to examples, I don't have a lot of examples on here yet, but there is one which is pretty good, which is the rehearsal pages that we made for the tunnel concerts. So what's one cool thing about the fact that Drawsocket is running in browser, so there again, there's the client and server I was mentioning before, and the server is handling the routing of the messages to the different clients, whereas the client is handling the processing of those messages and the performance of them in the system. And so because the browser part of the system is processing these messages that are coming from the server, it can also run separately from the server as a kind of standalone system. And so for the performance in the Elbe-Tunnel, we made an online system where performers could rehearse their parts offline, or online but offline from the networked connection. And so you can access those from this example page. So if you go to examples, collection here, and then you can select any of the pieces here. I'm just going to show you my piece. And so in this scenario, you can hit the play button and it starts the animation. And so here you can rehearse before going into the main concert. And you can also scrub along the timeline, stuff like that. And so all of this is actually in the browser. And we can see, just to get a quick peek, we can see here all of the code is in here. So there's all these layers and a bunch of graphics. And this is very handy, this interface here, when you're working in web browser, if there's the developers tools, which are visible. I always use the keyboard shortcut, but there are, developer, so view, this is in Chrome, view developer, developers tools, or option Command I on Mac. And so this is very useful for working with Drawsocket, because a lot of what we're doing is actually generating SVG, HTML, CSS, all of that kind of stuff, and it ends up here in the browser, and we can inspect it with this inspector. Cool. All right. So that's an example. So now I'd like to take you through the installation process. There's actually two different ways of running Drawsocket. I've just recently created a new NPM module, which is kind of exciting. So you can now do npm install Drawsocket. And so we can see that here, npm Drawsocket. And so there's two main ways to run the server so far. One is to run it from within Max as a using the node script object with the Max library, which I'll show you in a second, or you can download the UDP server from npm and run it remotely. And this is the main difference between these two, is that when it's running inside Max, you can send the messages directly to the abstraction, and it might be slightly faster to get the messages from Max to the server rather than using the server and sending messages via UDP. But it's pretty close. Okay, cool. So Drawsocket requires the Synmat ODOT library. And if we go to Max, so in Max, so just last night, this is very exciting. Just last night, ODOT has officially been added to the package manager. So now, if you go to Max and you go File, Show Package Manager, and let's say you are not already looking at ODOT, but you are here, you'll see a bunch of stuff like this. And so if you go up here with remote packages selected, you can type in ODOT, and then it will show up here. If you click on that, there should be a button that says install. And so then you can install ODOT from the package manager. So that's, you need this to be able to run Drawsocket. So please do get that installed. And to get started, I just will show quickly a little bit about ODOT, because we are using that a lot in the Drawsocket tutorials. So ODOT is essentially a OSC library with some added functionality for processing OSC bundles, and you can apply expressions, little bits of code on these bundles. So what is an OSC bundle? Well, an OSC bundle is essentially a collection of data that is wrapped together into an OSC packet as a bunch of bytes. So if we do ODOT print bytes, it has a special encoding because it's made for being run, or it's made for being sent over a network. And so if I send a message here, you can see it prints a whole bunch of bytes. Now, usually you don't have to look at this stuff. I'm just showing to be thorough. So a bundle is essentially a bunch of bytes that starts with pound bundle, has some null characters, and then some more data after that. That represents the data that you are sending in, or that you are encoding. So right now, I've just made ODOT pack, which creates an OSC message that uses an address that you give as an argument to the object, and takes whatever comes in this inlet and assigns it to that address. So in this case, we have an address of /foo, and OSC addresses always start with a slash. And we've assigned the value of 1 to the address of foo. And so the output, when you look at it in max, looks like full packet and some numbers. And so in max, we're sending these bundles around as a kind of wrapped object, just like you would, for instance, with jitter. We can see here, jitter is very similar in that it sends a type name and a unique identifier. And so OSC in max is essentially doing the same thing. We're using the full packet message is how OSC bundles are identified in max. And certain objects can view the OSC bundles. One of them is ODOT compose. So that's what we're looking at right here. Cool. So hopefully everybody has ODOT installed now. And so now let's install Drawsocket. So of course I happen to have it installed already, but if you go to the Drawsocket website, drawsocket.github.io, and go to installation, in the instructions here, there's a link here to download the latest Max package release from the Drawsocket Max repository. So if we click on that, that takes us to this GitHub page, Drawsocket Max. And over here in the releases area, you can see there's a releases tenor. And if you click on that, there's this top one is the one we want, Drawsocket-max tar GZ. So I'm going to click on that. That gets installed here. Show in Finder. It's here. I happen to have downloaded that recently. And also again recently. But so here you can unzip it and then drag this into the packages folder. And now it's prompting me to replace the one I have already.
Excuse me, Rama, the server was slow. Can you repeat how to get the Drawsocket DAR?
Yes, so you
on the GitHub.
So, yes, so you go.
I was not responding for a while.
Oh, okay. So you mean my videos?
After click on Drawsocket Max, then.
Okay, sorry, thank you. So click on Drawsocket Max, And that takes you to the Drawsocket Max GitHub page. And then there is a release here on the release tag here. And there's one that says TENOR release, which is one I put up last night. And then the one you want is this the top one with the little cube, Drawsocket Max tar gzip.
Thank you. We got it. Thank you very much.
Okay, great. Thank you for letting me know. Let me know if it freezes again. So once you have that, you can unzip it and then drag that into the packages folder. Oh, I think I was in the packages folder there. Okay, cool. So once you have that in the packages folder, you may need to restart Max. I'm going to do that now. Restarting Max. Takes a second. Restarting. Okay, we're back in Max. Okay, so in Max, once you've had that installed, you should be able to go to Extras, Drawsocket, and there's a Drawsocket intro page, which should look like this, hopefully. Does everybody see that? Yes?
Yes.
Great. Okay. So the first thing you need to do once you've installed the Max package into your packages folder is we need to actually install the Drawsocket NPM modules. So to do that, we first need to click on this top message here. So this is in the Extras, Drawsocket intro patch. And click NPM install Drawsocket. And we'll see here, Drawsocket NPM, so now it's downloading, and then once it's completed, it should say this, completed. And once that's working, we should be able to, or once that's finished installing, you should be able to hit script start, and then see these bouncing balls. Is that working for people?
It says wait.
Okay, yeah. Okay, let me know if anyone needs me to slow down. Okay, so here we are in the intro patch, and we can see we just have some bouncing balls here. So what's going on? Well, what we've done is the way Drawsocket works is that you log into a server, can be localhost or it can be hosted on an external server, and after, so there's a port number here. So the first thing is the IP address, or could be a website name, or localhost. So if it's running on your own computer and you want to send messages to it, it's or you want to, sorry, if you want to view the hosted web pages that are being run off of the local server, you can use localhost, or you can use the IP address. So the IP address is this list of 4 numbers with dots in between. And afterwards, there's just colon and a port number. The default port number is 3002. And after the port number, actually, let me just show you. So if you log into that URL directly, you'll get this message. It says, welcome to Drawsocket. You need to supply an OSC prefix URL in the browser address to receive messages. For example, HTTP localhost /svg draw will open a new web socket that receives messages, blah, 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 svg draw. So what that means is that you just need to add after this address. So this is your your IP address and the port with a colon in between. Zoom in a little bit. So after that, we need to give it a URL, and this is can be anything you want. And for instance, I'm just going to name this one Rama. And once I do that, then this browser window, so this is JWeb here. So this JWeb is a browser that runs in Macs, and this browser is now listening for messages that come to /Rama. So if we go back to the main view here, here in our o.compose, we're sending a message to /foo. So if I send this, you can see nothing, Rama is still blank. But if I change this message foo to be Rama, then we get a circle. And so what the server is doing is it's finding, or first matches this first OSC address, and then it looks for any clients that are logged in with that URL and sends them these messages. I'm seeing some stuff coming in on Slack, but I don't think it's for me. No, it's not. Okay, I'm gonna actually quit Slack. I'm getting this sounds. Okay. Cool. So that's how that works. So now let's talk more about what are we looking at here? So the main, actually, and I'm going to go to the help patch next. And that is just here. So here's the main Drawsocket abstraction. And actually, if you double click on it, it'll open up a patcher window, which you don't really need to worry about too much, but just to know that it's actually an abstraction. And so the node script object is the thing that's running the server. But you can just think of it as a regular Max object. And if you do a alt click on this or go to the help page, then there'll be some more information. Slightly less pretty looking. So one thing important to know, actually, I'll just demonstrate. So here we have a server running, and here's another Drawsocket object, and I'm going to hit script start. Oh, by the way, you only need to do this npm install thing the first time you run when you first install Drawsocket. After you do it once, it has all the code it needs. You don't need to do it again, unless you want to update to a newer version. So for instance, in the help patch, you don't need to do this again. But watch this. So if I go script start, it says here, port IP could not open port in use. And so that is because this server over here is already running with port 302. You can't have two servers on the same computer running on the same port. So I'm going to close this patch, not save. And once that's closed, it will automatically close the server, and then I can start this server again. Right. So there's this is the basic layout for a Drawsocket message. I think actually it's going to be maybe better if I just do it in a fresh patch. So if we make an o.compose object, we can start thinking about our Drawsocket. So let's say I'm going to send messages to Rama again. So the curly braces mean that it's an object. So Rama is the address, OSC address. Colon here means that we are assigning some value to this address in o.compose specifically. And o.expr code box, we'll talk about in a minute, has a slightly different, uses equals instead of colon, but compose uses a colon. So here we're creating what's called a sub bundle. So this is another, we just think of it as nested, a hierarchy of objects. So each object is wrapped in these curly braces. So for instance, if I said Rama colon curly braces foo1, here we have our outside object, this outside bundle, which is actually the whole o.compose object. And it has one address in it. And to that address is assigned one object with the name, with one address inside of that object called foo with the value of 1. So in Drawsocket, we use this extensively. And the main format for this is to have a key and a val messages inside this outer object. So the outer object is what sets the destination for this message, and the whole message is what's attached to that here. So everything that is attached to Rama is going to go to the Rama client. And every object that is going to a client needs to have a key and a val address. And the key is sort of context that tells the client what sort of values are you sending? Are you sending SVG values, HTML values? Are you sending animation stuff? And the reason why we have this key is because each of these types of messages might require slightly different handling on the client. So for drawing, usually we are talking in terms of SVG. And Drawsocket has a very direct mapping to SVG. So if we let's take a quick look at SVG on the Mozilla website. This is a really great website for getting any kind of web technology. They have excellent documentation. And so let's say we want to create some kind of SVG object. Let's say a line. So here we can look at an example of SVG. So SVG has a tag. So SVG is essentially a kind of XML type of language that uses these, to call them caret kind of tags that identify the beginning and end of a node. So here there's an open caret and close caret. And down here, there's an open caret and close caret with a slash before it. So here, this marks the end of the SVG block. And sometimes you can also see a single line that defines an element or a node. And this has a space slash end caret here. So this can kind of is a shorthand for defining a node in SVG. So it's helpful to be able to read SVG a little bit when you're working with Drawsocket, because actually what we're sending to Drawsocket is essentially directly SVG. So let's say we want to create exactly the same line. So I'm just going to copy this here. So we don't need the SVG block because Drawsocket actually already has an SVG in place. So we can just send draw messages into the pre-existing SVG block. Okay, so here we are back in Max. I'm just going to copy that in there. So here we see line has some different attributes. These things that come after the tag name are attributes. So to reproduce this in Drawsocket, we could say key SVG. So that tells Drawsocket we are going to make an SVG object. And Drawsocket has a couple special keywords. One of them is new. And new tells Drawsocket that you want to create a new object. So here we want to create a new line. Oh, and in O.compose, you always need a comma between elements that are in the same level, and except for the last one. So for instance, I'll show you here. So let's say, so we're making a new line and x1 will be 0. Now notice I didn't put a comma after that one because that's the end of this block. If I put a comma there, we get a red line here telling us that there's an error. But okay, let's continue. So x1, 0, x, y, the order actually here doesn't matter. So let's say x2 is 100, y1, 80, y2, 20, and stroke black. Problem? Ah, yeah. So here I'm missing a colon. Very important to have a colon. Ah, what else am I missing? Ah, I typed M instead of comma. Great. I love errors. Cool. So now let's try it. So it looks like we can send things here, S to Drawsocket. So I'm just going to paste that in our example patch here. And if I make a new Chrome browser, go localhost Rama, that comes up here. And then if we go back to Max, and I send this message, there it is. So I've just created that example from the MDN website here in Drawsocket. So as you can see, it's really very, very much a direct mapping of SVG. But because it's in Max, or because it's a real-time system, we can also dynamically change it. So for instance, here it's hard to see, but I changed it to blue. Here we can maybe, let's say, stroke width. I happen to know some of the SVG commands. So here I can make the stroke width wider, stuff like that. And because it's in Max, we could do something like, we can make this dynamic. So how are we going to do that? We will do that by using, I think, O.union. And so what I need to do, I'm going to zoom out a little bit. What I need to do here is recreate this bundle, this OSC bundle, using, but breaking it down a little bit, because what I want to do now is make a number. I want to make a float that sets the stroke width. So the first thing I'm going to do is make O.pack stroke width. And then I'm going to, basically I'm going to create this inner block first, and then this outer one. So the inner block, I'm going to actually, I want to copy all this other stuff, just the inside part, and put that in a new OSC message here. I'm going to just delete that stroke width part because I'm going to create that dynamically. And so what O.union does is it takes two different bundles. So here's one bundle, and remember O.pack is creating another bundle. So now if I hit this, it's being stored in O.union. It's a bit like ZL join. So it stores this in the right inlet. And now when I send something in the left inlet, we can see that it adds stroke width to the bundle. So it keeps all this stuff and adds this one new thing there. So that is our val bundle. So I'm going to do O.pack val. And I'm going to go ahead and put the key in here also. So key is SVG. And so o.pack, when it receives another bundle, will create a sub bundle from that. And so now we can see we have val and key SVG. So all that's missing is me, Rama. Oops, not caps. I think it's case sensitive. Actually, I'm not sure. Let's try that. Is it case sensitive? Yes. Okay. Whoa, doesn't like negative. Oh, that's interesting. It's not redrawing. Oh, okay. So what's interesting here now, notice that it got bigger and bigger and bigger and bigger, but never got smaller. And I was like, why is that not working? So what's actually happening here, if we look in the console, maybe I should show you quickly first before we do this. I want to show you what is going on in the Drawsocket page. So this is the HTML page of the Drawsocket client that's being used mainly. It imports a couple of scripts, but the main interesting part I wanted to show you is here. So this is the basic layout for Drawsocket. And this is slightly not indented correctly. There we go. So the main part of Drawsocket is in a, so this is HTML, what we're looking at here. And a div is a way of dividing the web page into different groups. So the div makes a division, which is actually the whole screen, and has a main HTML and an SVG object. And everything that we send into Drawsocket by default goes into the main SVG group. So that's a sub grouping. So group in SVG is like a div in HTML, basically. So it's a group of different objects. So when we look, that's to help us understand what we're about to look at here. So when we look at the inspector, if we go to the main div, SVG, main SVG, we see all these lines that we just made a second ago. And so why don't we see all of them? Well, actually, we are seeing all of them, but we didn't mean to create all of these. We meant to only edit one of them. And so the problem is that each one of these is a separate object. So the way that we can control a single object is a very important idea, which is the idea of an ID. And I'm going to show you that right now. One other thing I want to show you first is the wildcard URL. So the /* is a wildcard in OSC terms. And what that means is that it matches all clients. So when you send this to Drawsocket, it's going to send it to all clients, no matter what the URL name is. And what I want to do now is send clear. And for value, I can send also a wildcard to Drawsocket, and that will clear everything that's on the screen. So what we need is an ID, and we want to use the same ID all the time for this object. And just to show you what it would look like here, that is just another attribute. So I'll say ID, what's it called? Tenor. So now this line is called tenor. And if we actually, there's this utility in most dev tools where you can select an object. So if we select that object, it jumps to the object in the inspector. And here we can see the ID name is tenor. So if we go back to our max patch, I'm just going to add this ID tenor to this part of the patch. And so now we are always creating the same, we're always using the same ID. And that will, if that ID exists already, it will remove that ID, it will remove that object and recreate it with a new object. We can also, if the object exists already, we actually don't need to send anything other than the the ID when we want to update some value of it. So for instance, in this case, if we clear and create the line again from this here, what we've done is we've created a new line with the ID tenor with some values, and it has a stroke width. Over here, we have a dynamic dynamic patch that is just changing the stroke width. So you can say, here's the message that's coming out. Notice that it doesn't say new line. It doesn't say anything about XY stroke. It only has one part. And what that's allowing us to do is just address the object name tenor and change one parameter of that object. Any questions so far? Is everybody able to follow along pretty well?
I have one question for
Yes.
the address, like a localhost 3002. That is, you create this or is generated.
Right.
How can we know?
Right. So that's the default port. So localhost just means that's a default system IP address. You can also, another way to do it is to do 127.0.0.1. That's the same thing as localhost.
I see.
But the 302 is just the default. We can change that by setting the port attribute to the object. So let's say we want to set it to like 4444. We'll have to restart the server. So now you can see down here, it's changed the port number. And if I now go to 4444, oh, before I do that, you can see now it's blinking blue and saying reconnecting. That's because it can't find the server anymore because the port number has changed. So now if I go 4444, it reconnects, and then we can resend our message, right? Yes.
Great, thank you.
Thanks. Any other questions? Let's see. What's this? This away. And where are my notes? Right. Oh yeah. So another feature of Drawsocket is that the server is keeping track of messages that we've sent. So the idea is that if someone were to log into your piece after you've already sent the messages, it should remember. So here you can see that it's loading that line again, even though I refreshed the page. So that means that the page is being stored somewhere. And when you load in, well, not somewhere, it's being stored on the server. And when you log in, it asks the server for you to, or for it to send you the most recent information for this URL. Okay, so using this idea, you can make use of basically any of the SVG features. I haven't tested all of them, but I think it should work with a lot of them, especially the main drawing ones like circle, defs works, a Lisp. I don't know what FE means actually. FE. Okay, yeah, I haven't tested this FE blend stuff, but that might work. I think it should. It's basically just making SVG, so this all should work. All right, what's next on my list here? Ah, yes. So you can also send a list of, you can send a list of objects. So here we're sending 2 objects in the list. So the first one is here with the ID bar. And in o.compose and in JSON, the array character for this is the square bracket. So open and close square bracket. So first we open a square bracket, then we have a curly brace with inside a bunch of, here is SVG. So these are SVG attributes, plus the special new keyword to create a new element. And then we have a comma with a second one. So this is a list of two. And what's important here is the order to point, or what's important to point out is the order. So here you could see this orange circle with a yellow circle inside. If I clear that and I change this order, we won't see the yellow circle because it's too small. So here we only, oops, we also have to plug it in. Okay, so here you can see we only see the orange circle, but if we go and we jump to the place in the, using this little this selection tool, you could see that the yellow circle is there. And if you put your mouse over it, you could see that it's kind of highlighting something there, but we can't see it because the order of the SVG is important. And that means that this orange circle has a radius of 10, where the yellow circle only has a radius of 5. And so that means that the orange circle is actually blocking the view of the yellow circle. Actually, in the browser, I think I can just drag this up there. Yeah. So now if you change the order, now you can see that yellow circle. Similarly, when you have a list of objects, the order is maintained. So if you first draw the yellow circle with a radius of 5, and then the orange circle with a radius of 10, the orange circle is going to block the circle. Although if we offset this by a little bit, there, I'll just make it offset a little bit more, make this clearer, not too much. It has to be perfect. All right, there we go. Oops. Also, if you're zooming in and you have your mouse over here, it zooms the wrong thing. So here you can see that the orange is on top of the yellow. And I'm going to copy that again here. And here, the yellow is on top of the orange. That's a better example. Okay. So that gets it right. So that's the stacking order. Another cool thing is layers. So because of the stacking order, you can actually use this to create different layers that can move separately. So in this example, and this is in the help patch under SVG layers. In this example, we create first 3 group objects. So if I send this to Drawsocket, we don't see anything here, but if we go into the inspector, we can see that we've just created the back, main, and overlay objects. So here, back, main, overlay. And notice that the order is the same as the list that we sent here. So that functionality gives us the ability to add new graphics into each one of these groups. And because these groups have a set stacking order, the objects that you put in also have a stacking order inside the parent stack, or inside the parent group. So using the parent keyword, I've already drawn it here. Oh, I can't, there we go. Oh. Zoom out a little bit. Okay. So what we've done here is we've created a rectangle in the parent group. So the syntax for that is to say parent and the ID of the object that you want to insert a new child into. So here we have selected the back ID. So here ID back, and we create a new rectangle with the ID R. Not sure why it's R, but, and apparently the rectangle has X, Y, width, and height as parameters. And again, you can look that up on the SVG documentation. So here, yeah, X, Y. Oh, RX, that's interesting. I've never done that before. So let's add an RX here just for fun. So no comma here at the end because it's the end of that block. Whoa, that's cool. Let's make that a little less. There we go. So now we have rounded edges. And so if this rectangle was not on the back layer, just like we were looking at with the orange and yellow circles, the black would block out a lot of the other images because it's bigger, right? And in the middle layer is this pink circle, and on the top layer is this light gray circle. So here now I'm going to add new things into these layers, one into main, one into back, and one into overlay. Now, I'm sending a list in here, and the order is maintained when Drawsocket gets it, but because the parent objects have their own order, these will have maintain the order of the parent objects. So here we've created a font, a font element, which is this clef, using class bravura text. I guess that's a class for the bravura font. It's been a while since I looked at that. Then we have a rectangle, a red rectangle, which we see there, and a circle, which is overlay on top. So we can see, even though the order here is not the same as the stacking order, because the stacking order is created with these groups, the overlay order is of the groups, not the order that you sent the messages in. Hope that makes sense. Another way to add child elements is using the child keyword. So it's kind of the opposite of the parent. Let me just clear everything here. Sorry, I'm trying to make sense of what we're looking at here. I'm a little confused. Okay. I'm not sure why we don't see this here. I guess we can look in here. Oh, I cleared all. Okay, let's go back. So here I'm going to clear everything. You can also clear individual groups by using the IDs of the groups with the clear message. Does not change anything. Also does not remove the group object. Okay. But when you do clear wildcard, that clears everything. So here now I'm just going to recreate our groups. And now if I go to this example, still not visible. Okay. So I'm not sure why we're not seeing this ID 2. So let's try to find that. So if we investigate in here, group E, GG. Oh, it's way down there. Wonder why. Let's make this smaller. So you can also edit right in the browser window, which is pretty helpful if you need to figure out what's going wrong. Okay. So this was just set too high. So I'm going to set this to be like 200, which is what it is now. I set it to 150. There we go. So what we did here was we created a new group called Group E, and then we added child elements that automatically get inserted into that group when you create it. So you can either add child elements into a group on creation when you first send the message, or you can use this parent system to add elements into that. Now this is essentially the system that we used when we created the tunnel pieces. Do I have that open? No. In the extras menu, if you go to Drawsocket, scrolling score, there's an example here of, oops. All right, let me close the help patch, start up in this server, which is on 302. Okay. So this uses a similar idea. And first what we do is, so this is to create a score that we want to animate. So here we're using the wildcard URL, so that means it's going to go to everybody. And we say key SVG, and we're putting a new, wait, sorry, let me just look at this for a second. Okay, so this is slightly, so what, okay, slightly different topic than I was planning to introduce, but no problem. I'm gonna have this last sip of coffee too, sorry. So there's a special functionality in SVG called the defs. So the defs are a special div type inside SVG, which is not actually drawn, but allows you to store prototypes of graphic objects that you can then refer to and make copies of them, kind of like a stamp. Like if you were to create a stamp and mark it in ink and make stamps of your symbol, the defs create prototypes that allow you to quickly reproduce the same object, but you can recreate it in different places. So I'm using that in this example to create a note. So a note line. So here I say parent defs, so that's creating a new object that's going to go into this defs element. Create a new G, so G is the SVG group. Don't forget we're a key SVG. So new G, ID note line, and then I'm just creating the children of that, our new note line group on creation of the group. So this note line group has two children. One is a line. I think I need to add a stroke here also. So if you're doing this at home, probably need to add that if you want it to be visible. So that sets the stroke to be black, stroke width is 1. And then there's another object that is part of this note line, which is a circle, which is essentially the note head. That has sorry. The position of these can be so these positions that we set here are relative to the stamp. So if you think about the stamp as having an origin of 0, 0, x, y, then the numbers you give here are kind of within your bounding box of your stamp symbol that we're going to use later. So with the defs, you can create a prototype, and the way you use it is another special SVG type called use. So this is all just SVG stuff there's lots of tutorials online if you're interested. And I'm happy to help also with that. So here we create a definition note line that has a line and a circle. Then this is the part I wanted to show you is we create another group called score. And so here, if I create, I have to start the server first, I think. And then, and I just zoom out a bit. Okay. So here I've created a new score group. And here in the main, so we can see here in the defs, we find our note line. And in the main SVG, there's a score now. So we just created this and the line. So this is what will be our playhead. And then, like I was mentioning before, I'm going to use the use SVG type. Oh, this is O.expert code box, by the way. So O.expert code box takes an OSC bundle, and you can run expressions on that. It looks like here we're actually just doing essentially what we were doing before with the union. But here we're using O.expert just, I don't know why I did this. It's one less object, so it's kind of nice to do it this way. So these, this bundle comes in, so O.pack can have different inlets. Here we have 3 inlets, and we have an Uzi, which is going to create 1,000 notes for us inside the parent of the score. So if I click this, we get a bunch of notes that appear over here. And here we say href pound note line. So that's, again, this is a special SVG, it's a very standardized method for using prototype symbols. So once you've done that, then actually let's look at it in the score, or let's see the score in the web page. So here in the main SVG, there's a group score. And then in the score, here we see all of our note lines that we just made. There's 1,000 of them. So there's going to be a lot of stuff in here. And each one of these says use and has an href of the note line. The note line is referring to our definition. And so each one has a different ID and a different XY position. So it's just taking our prototype of note line and creating a new one at these different X and Y positions. But importantly, they're all inside of the score. Now, why is that important? Well, that means that we can now create an animation because we want someone to play this. This is like a score that someone's going to play. So we can use the tween command. So this is uses the GSAP. I think there's a link in the help page. Yes. So if you go to the help page for Drawsocket, and you go to tween animation, there's a link here that takes us to the documentation page for, where's my mouse? There it is. For GSAP. So this is a green sock animation, and inside there is a tween command. I think this is the same, yeah. So here you can read more about what all the different options are. And what we are doing back in our score playing example is we're creating a new tween. We don't use the new keyword here because I guess every time you do this, it creates a new one. So we say key tween. That tells Drawsocket that we're now going to address the tween functionality. We give the tween an ID, just like we did for our graphic objects, because we want to be able to address this tween later. So the tween is an animation process. So we're creating a new animation process that has an ID identifier. Then we give our tween a target. So this is the thing that it should animate. And here, our target is the score. This pound sign here, this is a typical CSS selector format. And so pound means ID. So this pound score means ID score. And we can remember that the group that we made here had an ID score. So then we set some other parameters for our animation. So we set the duration, which here is, I believe, in seconds. So this is now 500 seconds. And we set some vars. And what we're telling it here is to, over that 500 seconds, to slowly move the score group object negative 20,000 pixels. So negative 20,000 pixels, and the x-axis means that it's moving from right to left. And we're setting it to be paused. Okay, so I'm gonna go ahead and click that. And now we have these subpatchers, which basically have these two messages, play and reset. So here we say key tween, ID score tween. So remember, this is the tween we just created. And then we say command play. So then if I hit play, it starts playing on the screen. And so what's happening here is it's moving. Actually, if we look in the browser window again, we can see that the score div is being constantly updated. And that's what this tween library is doing for us, is it's actually handling a matrix transformation of the object. So there's a lot of different functionality you can get out of that. Okay. There's lots more, of course. We're starting to get towards the end of the session here. And I wanted to show you at least one other thing, which is that there's also a very exciting new feature, newish feature. Where's the, well, there's a few things. Okay, one is that you can also run this on a real server. Where's that? Not there, not there. So you can also run Drawsocket on a public web server. And so I've done this for today. I've created a URL that you guys can all log into. So here, I'm going to post it in the chat window. I think, where's the chat window? Yes. Okay, so in the chat window, you should all find the URL of the public Drawsocket server. And so when you click on it, it should take you to this page here. So just like before, you should enter a URL. So why don't you just put your first name there? And you should see something like this. Is everybody seeing this?
Yes, I see.
Great. Cool. So now I want to, okay, so here's some other fun stuff. So if you're on there, and so now I'm going to use the same kind of idea. And oops. No, not that. This one. Yes. And so, for instance, you can have a real-time control. Here I'm sending a bunch of messages that's moving the orange dot around on your screens, hopefully. And that's happening in real time. So that message is coming from my computer, and I'm using this there's a special abstraction here called signal peer, which is basically just reformatting this message and sending, because I'm running in Max, there's a special feature in the Drawsocket client that it detects when it's running in Max, when it's running in a JWeb object. And using that, you can send messages from clients to other clients. So actually you all could be sending messages to each other, chatting or sending different images. There's also, you can also, because it's, so this on the server is running just the Drawsocket NPM package, and it has a built-in server in there. So if you run that, then it also opens a UDP port, and you can also send UDP messages. So what did I want to do? Oh, right. So now I'm just going to copy this UDP send and bring it. Oh, did I close? I wanted to bring it back to our scrolling score examples. I'm going to open that up again. So here, I'm just going to paste in this UDP send object. Actually, I'm just going to replace that on Drawsocket, because now I'm sending all of this to the public server. So now I'm just going to do the same thing that we just did a second ago, except I'm going to again add this stroke back in. That's something I forgot to do. So now you should see a bunch of stuff there. And now I'm going to hit play. Oh, first you have to create the tween, then you hit play. So now you should all see. So now we can all have a concert together where we play stuff remotely. And actually during the, so this is what we used for the tunnel project. And also we'll be using this system for the choir concert that's happening on Tuesday night, I think. I forget which night it is. Yeah, any questions?
Looks so great. Yeah.
Yeah, so it should be, I mean, hopefully pretty easy to get started with, because you can use SVG, because it's really very well documented and very, there's a real spec for this. And so the main challenge, I think, is just getting used to the ODOT system for doing this. But once you get used to it, it's very powerful, because it allows you to do like everything dynamic. And I'm sure there's some other good.
I have a question.
Yeah.
Rama, do you think it's possible on a future update to build in objects which has all these SVG orders included, so that I just press a word line and it gets the right wording of creating a line? So sub-edges before, so we don't have to look it up.
You mean?
Well, just I think as a composer, or as I think of my students, it would be an easy access, or the next step of access to, if I look for a line or a circle and I go to the SVG page and look up how to do it properly, to have it built in Drawsocket objects,
right? Yes,
or object which generates it for us out of the library.
Thank you for asking that. So Drawsocket is a kind of low-level tool in a way, because it requires that you make all of these, that you know what these things are. But for instance, actually already in this example, we are saying href note line, and so that has already stored this symbol, and so now we don't actually need to recreate that every time. So you could potentially have one file that defines all of your symbol types, and then you can refer to them this way and make it more simple. But let's say, actually, that's a nice segue to showing you the new version of Symbolist quite quickly, because maybe some of you have seen Symbolist in previous TENOR. Did I do it? Yeah, we did in Montreal. We presented a first version of Symbolist that Jean Bresson and I worked on. And since then, I've created a new version that runs in, that uses Drawsocket as a front end. And so here, for instance, is a editor that you can use to create similar types of objects. And then this is already all Drawsocket information that could be, actually it has already a playback system. I'm hesitating a little bit in my mind because I'm also realizing, yes, of course, well, you can also use Illustrator. This is something I did actually for that piece in the tunnel. What I did in Illustrator was use the export features from Illustrator to control layers. Sorry, to make different groups. So for instance, here, if I make a rectangle and here I make a line, if I go to the layers and I create a new layer, layer 2, and I move one of these things to that layer, and then I export this as SVG. Let's just put it on desktop. Just to show you what show code, right? And so here, it's a little hard to see, but there, actually, never mind. Let me not do that. Export there, and then if we go to open that here, desktop. Oops. Format document. So now we can see that Illustrator, when I exported that, created the SVG here for me. And there is a script that I have to update a little bit, but what you can do is you could use Illustrator and use your layer IDs, and you can use these as like instrument names. And this is how I did the piece with the 144 instruments. I made a score in Illustrator, and each instrument was on a different layer. And then you can then parse this file, and I have a script that's was included in the previous version of Drawsocket, and will be again. I just need to edit it a little bit, where you can load a SVG file that you've exported from Illustrator and generate a JSON file with all the Drawsocket formatting for that. So you could do the composition graphically in Illustrator, and then be able to distribute the different parts to different performers using Drawsocket. Eventually, I would like to be able to do all of that in Symbolist as well. And let's see, what did I want to show? Yeah, so in Symbolist, I'm now creating, and I think this is more for next year's TENOR. I will be demonstrating this a bit more, but essentially in Symbolist now, you can create a definition of a symbol type, which has a Drawsocket format inside of it. And so you can then define, if you know that you're going to be working with certain types of symbols, you can define those here. And then when you are in the application, you can then manipulate them graphically. One cool thing, I don't know if you notice here, but if, not that one. Because of the mapping, you can see here when I'm in Symbolist, I've selected one of the defined symbols, and when I move my mouse around, I'm holding down the command button, you can see that it says time, pitch, and duration. And so what that's doing is actually it's mapping between perceptual parameters, time, pitch, duration, to graphic parameters. And just quickly before I wrap up, I'll just show you. Oh yeah, so maybe before I do that, so you can also, like, I'm working on some WebGL stuff. There's also working on some tools for generating, oops, not 100, let's do this one. For generating like subdivisions and things like that. So will this work? Maybe this will work, let's see. Yeah, so if I hold down Shift and I do this, you can see that it's snapping to these different positions. So in this way, you could create polyrhythms and so on. So I'm excited about this. This is going to be cool coming up. There's still quite some work to do on that, but it's getting there. And just to give you a quick intro to what that's all about, is essentially there's this relationship between graphic data and semantic data. So Drawsocket is handling mainly the graphic representation. And so what Symbolist is adding then eventually will be a mapping bidirectionally between graphic representation and the semantic meaning of that representation. And so that could be, for instance, generated from some kind of generative process, computer-aided composition. So that comes into the system via the semantic data. So the pitch, duration, things that are like describing the meaning of the symbol. And then the definition in Symbolist maps between the meaning and the graphic representation. And then separately, the meaning can also be sequenced and played back. And so that's what I'm working on right now in Symbolist, is moving from semantic data, graphic representation, and then of course, when you actually are doing that, it's getting mapped to several different parameters from the semantic data. And when you edit it graphically, then you need to then update the semantic data from the changes in the graphic. So there's this bidirectional mapping. Yeah, I'll just stop there. Cool, any other questions? There's the website. There's feel free to, of course, email me. And I should also mention on the ODOT now has a Discord server, which just started today. So if you are interested in getting more involved with ODOT, you can download it from the package manager and join the Discord group if you have any questions. I'll be there. And I'm sure Drawsocket can fit into that place also.
That is in Slack or?
That's in Discord. So if you go to the ODOT website, ODOT GitHub repository.
Okay.
Somewhere in here, discussion, there's this Discord.
Okay, I see, yeah.
So that's a good place if you want to get help with ODOT in general. And I don't know, John, I mean, I would assume that we could also discuss Drawsocket in the ODOT Discord. It's kind of closely related.
I mean, yeah, we can make a channel for it, or a channel for projects that rely on ODOT or whatever.
Yeah, cool. Yeah, so any other questions? There's the website for Drawsocket. On this front page, there's no instructions, but what's happening here is there's a little version of Drawsocket running here that you can send messages to. And hopefully it's not really done yet, but eventually the API, I hope to have examples like that where you can click on them. But all of the messages that you send to Drawsocket. Most of them are on this API page. And then another good place to learn about it is in the extras menu in Max. There's a bunch of examples. And there's also in the Drawsocket, in Max, there's also a Drawsocket vignette that basically is the same as what's on the website. But if you're offline, maybe that's handy. Yeah, so anyway, there's a lot more there that I didn't talk about, but I think we covered a lot of it. You can also create your own functions and call them. I just want to share that because it's kind of fun. So here, I create a function that has, every time you call it, it creates a new circle, but it calls some random functions. And so now, when I call it, you can see on each client here, it's a different position because actually each time it's called, so here I'm not directly generating this object, I'm calling this function that I created, and then it creates one in a random position. All right, so that ends our Drawsocket extravaganza.
Wonderful. Thank you. Great introduction.
Thanks,
Very
everybody.
good.
Yeah, thank you so much.